But let's take a look at this. If I'm going to push this lift this box up to the top of a shelf, how do I have to lift it to the top of the shelf? I have to use a force equal to all of its weight to lift it. Okay, I have to use a force equal to all of its weight to lift it some distance. Now, if I put it on a ramp and raise the ramp, and I'm going to try to lift it, what am I actually having to lift it against? If I'm pushing the object up the ramp, what am I actually pushing against? And we're going to assume no friction. If there's friction, it's a different story, but no friction. Which way am I pushing? I'm pushing this way. So what part of gravity am I pushing against? You're pushing against this triangle leg. Well, this triangle leg is a certain size based on the angle of the ramp. So watch what happens to the distance between those triangles. Look here. And now let's go down further. Look here. So what am I pushing against to raise that box up to the height I want? So where is the biggest arrow that I would have to push against? The biggest arrow would be straight up and down. I'd have to use all of the weight of the object and push against the entire weight of the object. But as I lower the ramp, the amount of gravity that I have to push against gets smaller. So as I lower the ramp, in other words, make it shallower, the less and less I have to push against the weight of the object. Okay. Now, in the ants on a slant gizmo, the question is asked, how does the normal force help us? Well, it's the same kind of a principle. As we change the angle, what gets bigger? What's helping us push? Well, the normal force is actually helping us push against those things. Okay. So, because it's taking part of the weight of the object off of us, so we're not having to hold that piece of weight, and we are just having to push against this tiny little piece. Okay, so the normal force is holding all of the perpendicular part of the weight, and we're only having to push against this little parallel part. Whereas if we make the ramp steeper, then we're having to push against the parallel portion of the weight more. Okay. Now, the gotcha with this is to make a ramp shallow, guess what? We need a longer ramp. That's why if you watch a wheelchair ramp, it usually winds back and forth a couple times because there's just not room to make it straight, okay? So you got to go up a little bit and then they turn around and go back. So that way they can save space, but you'll still get you up the ramp. All right. That concludes this video, this short video on the normal force and lifting objects up a ramp.